Well, we're back again for the fourth marking period this year, and we're starting off in week one doing a review of the law of sines, looking at how to use the law of sines to solve triangles in the SSA case, or the ambiguous case. And we're going to start off today reviewing the 10 practice problems I gave you that ask you to determine the number of triangles that are possible when we're presented with two sides of a triangle and one of the angles opposite one of those two sides. So if you haven't yet given these problems a try, I'm going to give you the opportunity before each problem to pause the video, try the problem on your own, then you can unpause it and see if your answer goes together with what I'm going to do. So let's get started. Question number one. Here, question number one, we have angle A. And the first question we're always asking on these SSA problems is the angle given obtuse or acute? In this case, A is 113 degrees, so we know that it is, in fact, obtuse. Given that the angle is obtuse, we then have to ask ourselves the follow-up question, is A, right, is the side opposite of our angle here longer than the other side that we're given? So is A greater than B? In this case, A is 26, B is 14.1. So 26 is most certainly greater than 14.1. So we know that there is one triangle possible. Take a try on number two and unpause when you're done with it. So for number two, we still have angle A. In this case, we're still obtuse. We have a 96-degree angle, so that's greater than 90. We're obtuse. And now, again, we ask ourselves, is A greater than B? Well, in this case, our A is 13, and that's less than 16.8. So no, A is not greater than B. So in this case, we have no possible triangles. So between number one and number two, those are the two main situations that we get into when we have an angle that is obtuse. Give number three a try and then we'll go over it. All right, you'll notice from number three that now we are in the land of acute angles. So since this is an acute angle, what we want to look at is what is the height of the triangle here. And one of the main things about this is that we use the formula that the height is going to be equal to the adjacent side, in this case B, times the sine of the known angle. In this case, it's going to be H is equal to 15 times the sine of 18 degrees. And this is approximately 4.64. Now, we have to consider what's the relationship between A, B, and the new H. And here we see that 4, which is our value for A, is less than 4.6, which is our value for H. So since A is less than H, this is the situation where we have no possible triangles. Okay. So as soon as you see this H greater than your A value, you can stop working. You know that there's no possible triangles. Go ahead and give number 4 a try. Okay, for number 4, we're in the acute situation. And again, if we want to follow the same procedure each time, and I recommend that you do, we're going to figure out here that H is going to be equal to 13 sine of 54 degrees. And that's going to be approximately 10.52. Now, some of you may have realized, might not have done the H calculation, which would be fine in this case, because the situation that we're having is that we have that one acute triangle situation that does not involve the height of the triangle. Recall that if we have an acute triangle and it turns out that that side opposite is greater than or equal to our adjacent side, we don't even have to figure out H in this case. We can just say that we know that there will be one triangle. Okay. So I generally do say go ahead and figure out the height every time because it's a good habit to get into. But sometimes you can go ahead, look at that acute, and then if you want to, the first thing that you're going to look at, the first decision you want to make is to look at your A and your B. And if you see a situation here where A is greater than or equal to B, you don't even have to calculate H. You can just say, since A is greater than or equal to B, we know that there's going to be exactly one triangle. All right, go ahead, give number 5 a try. Number 5, we're in the acute case. We can look at our A and our B. In this case, A is not greater than B. We're not equal to B. So let's go ahead, calculate our H value here. And that's going to be 17, which is our B, times the sine of our angle, 64. Plugging that into a calculator, it's going to get us 15.28. Okay. Now we'll notice that our H is less than our A, and that A is less than B. And this tells you this is one of those cases where you have two triangles. Okay. Go ahead and do number 6. All right, number 6, we are back into looking at obtuse angles. The one thing I want to bring your attention to here, and this is going to be one of those places where you can trip up, is that look at what our angle is. Our angle is now B. It's for vertex B, which means that our opposite side is B. So in all those cases where we were considering is A greater than B, that's only in the case where the angle is A. We're really talking about when we're asking is A greater than B, is the opposite side greater than the adjacent side. So when we have a different angle, a different vertex that we're going from, we're going to have to switch around our order of our sides. So here, since it is that B, the question we're going to ask here is B greater than A. In this case, 29 is definitely greater than 25. And that's going to imply that there is exactly one triangle. Okay. This is going to be possibility for a very common mistake to be made. So I want you to make sure that every time you're doing these problems, that you're looking at what the label for the angle that you're given is, making sure that you're lining up your inequalities with the side opposite to that. Go ahead, give number 7. It's the same kind of idea. Okay, so number 7, again, we have an angle that is B. And again, but in this case, we're going to have an acute angle. Okay? So our question here is, what's our height going to be? In this case, height is going to be equal to A sine of B, because our A is going to be the adjacent side and B is our angle now. So if we fill in from the information that we're given, this will be 13 sine of 75 degrees. Putting that into a calculator, that's going to be approximately 12.56. Now, when we're comparing this height, we need to compare it first to B. In this case, B is less than H. Since B is the opposite side, if the opposite side is less than the height, that's the case that tells us there's no triangles possible. Go get ahead, give 8 a try, and we'll come back and work on it. All right, for number 8, we are back to angle A's, and we're back to acutes. So in this case, we have an acute angle, and we have A less than B, so we're going to want to figure out what H is. And H in this case is going to be 36 times the sine of 28 degrees. Plugging that into a calculator, we get 16.9. And since that H is less than A and A is less than B, this tells us 2 triangles. All right, we're going to move on to number 9. Number 9, we're back dealing with angle B, so we're not with the angle A, so we have to consider what sides are opposite, what sides are adjacent. In this case, B is the opposite side, C is the adjacent side. So with an acute triangle, first thing that we have to consider is that opposite side greater than the adjacent side. Okay, in this case, B is greater than our C. We can stop right there. We don't have to figure out what the height is. That tells us 1 triangle. So this is the tricky part here. It's just recognizing that with B being the angle, we're going to be asking ourselves first, is B now greater than C? And it was. So we had 1 triangle. Don't need to figure out H. Go ahead and do number 10, and then we're going to finish this up. Okay, for number 10, the first time we're seeing C is our angle. Right? But it's just the same as always. This is just telling us, since C is our angle, the value of C equals 13, that's our opposite side. And given that this is an obtuse angle, now the question we're asking ourselves is C greater than A? 13 is not greater than 16. So this one we're going to finish off with no triangles. And that's our 10 problems. If you came through here and you were able to get most of those, very good. If you were tripping up here when I changed what angles we were dealing with, that's a very common mistake. Go back, do them again, get practice on them, and then go ahead and try that exit ticket for this lesson. As always, any other questions, please come see me during office hours.